Okay, the second part of the worksheet here, this is the top of page 3. It says that there are 8 red beads and 12 blue beads in a bowl, and they're asking us in number 16 to make a tree diagram. Having trouble with my starboard actually accepting what I'm drawing here, especially when I get into drawing lines and stuff. So I've gone ahead and made it over on a fresh page. It accepts what I'm writing a little bit better. So um, if you draw a red, for example, so starting with 8 red, 12 blue, if you draw a red, that would take you down a certain branch on your tree that would be a probability of 2/5. Okay? And then for blue, that would have to be 3/5 for two reasons, right? For one, because 8/20 is 2/5, that's your red. 12/20 would be 3/5, that's your blue. Also, without even having that information, these two numbers would have to add up to 1. Right? And hopefully that was clear in your 12-2 homework about tree diagrams. Obviously, you're going to have to cover all the probability. Remember the question we had in the first part of this worksheet where it says, when you have all possibilities considered, what does it add up to? Well, that would have to add up to 1. And the same thing here, 2/5 and 3/5 have a sum of 1. Now, the question was clearly said without replacement. So supposing you did draw a red, you're kind of going down the branch of the tree. So now you're located here. But you have removed a red now. So there is no longer 8 reds out of 20. There's 7 out of 19. That would go here. To draw another red, there's a 7 out of 19 probability. There are still 12 blue, so this would be 12 out of a total of 19. And again, 7/19, 12/19, those add up to 19/19, which is 1. Let's just continue down the red path to the end. If we are to draw another red, that means that we've drawn 1 and then 2. That means that we'd be left with 6 out of 18. I'm going to go ahead and reduce that fraction. 6/18 is 1/3. Okay? Now, if you understood what we did on this set of branches, or maybe we should call that a fork, and on this fork, well, then it would be clear that this would be 2/3. And you can check that if you want to. We still have 12 blues in the bag, and there's 18 total beads. 12/18 is 2/3. And again, 1/3 and 2/3 would have to add up. Okay, so with that established, let me just quickly put in the rest of these. Well, I'll go into detail just a little bit more. If we went blue then red, right? We went blue would be 3/5, then we take a blue out. Now there's 11 blues left out of 19. That would go here. That would mean that there are still 8 red out of 19. Okay, so let me just quickly fill in the rest of these. And you can verify them if you want to. I promise they're right. It's a coincidence that those two are the same. It's actually a little bit more than a coincidence, but for our purposes right now, well, I'll explain it. Why not? Red, blue, red, and blue, red, red are going to be the same probability. And we're going to encounter that a little bit later in the video anyway, because I did 2 reds and 1 blue. Red, blue, blue is 11/18. Blue, red, blue. You still had 2 blues and a red. It sort of evens itself out in the calculation. We're going to see that coming here in just a minute. Okay, so here's a completed tree diagram. It's got all the probabilities, and call the red and the blues, the R's and the B's on this. I might call those like nodes. I think that's the right word to use, node, N-O-D-E. And the probabilities are necessary because now what we're going to do is we're going to calculate some probabilities going down each branch. What's the probability as we look at number 17? I'll go back to it here in just a second on the screen. But number 17 says, what's the probability of drawing 3 red beads? Well, that would be to follow the branches down red, red, red. And as we've already discussed, this would be a product. Okay, so going back to this now, this is how this should be written. Again, in the previous lessons, the video, we said this is the correct way to show probability. The probability of red, red, red would be 2/5. And again, pardon my handwriting because this is, I promise I don't normally write this way. but the starboard is giving me trouble. 2/15 times 7/19 times 1/3. Okay, and what that comes out to then is 14 out of 285. Okay, and again, just so you understand, I'm looking at the tree diagram and I'm multiplying these three numbers because it was asking about red, red, red. 2/5 on the first one times 7/19 to get another red times 1/3 to get a third red. And that comes out to 14 out of 285, which is about 5%. Okay, now for 18, I moved my work over here just so I have a little bit more space to show that. And it says, what's the probability of drawing two red and a blue? Okay, now I sort of hinted at this before, but let's just go at this honestly for a second. The probability of drawing red, red, blue, that would be one way of drawing two red and a blue, would be 2/5, verify this if you like, on the tree diagram, times 7/19 times 2/3, which would be 28 out of 285. Okay. Another way to show that, or another I guess combination is what we want to say, would be red, blue, red. That would be a way of getting two red and a blue. And that calculation would start with 2/5 still, but then it would be times 12/19. I don't want to click back and forth to the tree diagram over and over again, but if you need to stop and look at this, just pause the video and look. And interestingly, and I don't know if you would have expected this, this is also 28 out of 285. And same thing here, this would be 3/5 times 8/19 times 7/18 comes out to 28 out of 285. And you do need to add those probabilities then, okay? So one trail on the tree diagram added to another one would give you that probability to cover all possible ways to get two reds and a blue. So you could add these three fractions together, or in fact, probably the easier thing to do would just be to go 3 times 28 out of 285, since it's the same fraction each of the 3 times, which does multiply and then reduce to this fraction, 28 out of 95, which is approximately 30%. Now again, you should be conscious of how they want you to express the answer. If they said simple fraction, simplified fraction, 28 out of 95 is a great way to express that. If they said decimal, about 0.3. If they said nearest tenth of on a decimal, about 30% is to the nearest percent. Okay. 19, I've already partially completed that one. It says, what is the probability of exactly 2 being the same color? All right, now let's think about that. Exactly 2 being the same color. Well, there are 6 different possibilities where exactly 2 are the same color. So one approach would be to calculate those 6 different probabilities and add them up. Okay, so red, red, blue, blue, red, blue, red, red, blue, blue, red, all the different ones. And you could do that and you would get the correct answer. However, since we've already done the work, well, think of it this way. Since there are 8 possible outcomes, does it make more sense to find out these 6, or does it make more sense to find out the remaining 2 and then subtract that from 100% or subtract it from 1? Especially since we've already calculated the probability of red, red, red in number 17, right? So the only way, what I'm saying is the only way that you don't have 2 and 1 in a combination of 3, the only way that you don't have 2 and 1 is if you have 3 of the same thing. There's no other possibility, okay? And we've already calculated probability of red, red, red. It came out to 14 out of 285. You can see that in number 17. So I've done the same thing for blue, 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 which is the only other possible outcome that isn't 2 of one and 1 of another, okay? And that comes out to 11 out of 57. And then finally what we'd want to do is go 1 minus the product of those two fractions. 14 out of 285. For some reason, it's the denominators too that this thing just does not like. Probably like some of you. See, my 11 looks good. My 14 looks good. My 57 looks terrible. That comes out to 72 out of 95, which is approximately 76% if you did it on a calculator and turned it into a percent. Okay, finishing up. Number 20. What is the probability of drawing 2 red given the fact that your first bead is, drawn was blue? Okay, now that's a different question. Back to the tree diagram. If your first bead drawn is blue, you're not here anymore. You're here. You're moving up to the second branch. So there isn't a calculation of 3 numbers, it's only 2 probabilities. Given that you've already drawn 1 blue, what's the probability of drawing 2 red would be down this branch, red and then red. So this has nothing to do with 3/5. We've already drawn a blue. Now we're here, and then we can answer the question, and it would be 8/19 times 7/18. 8/19 times 7/18, and that comes out to 28/171, which is approximately 16%. All right, finally. A class has 24 students, 14 girls and 10 boys. 3 students are randomly selected to represent the class at a meeting. And 21 says, what is the probability that there are 2 girls and 1 boy selected? Okay, so this is kind of a repeat, so I've already gone ahead and done the work, and we'll talk through it just a moment, and we'll be done with the video. Probability of girl, girl, boy. You see, they're going to select, and then select again, and then select again. And the probability of getting a girl, and then probability again of getting a girl, and then the probability of the third draw getting a boy can be calculated this way. 14 out of 24, because there's 14 girls out of the total group. Then to get another girl, now we have 1 less girl to choose from and 1 less overall. There are still 10 boys in this last one out of 22 that are left. Comes out to 455 out of 3,036. Not surprisingly, because of the last example, the probability of girl, boy, girl is 455 out of 3036. And check it if you want, the probability of boy, girl, girl is 455 out of 3036. So just like the last one, I've multiplied that fraction by 3, and you get about 45%. 455 out of 1,012, which is about 45%. One last quick example, the probability of getting 3 boys is represented by BBB. And notice in this case, it's just kind of descending, 10, 9, 8, 24, 23, 22, and I did that calculation. 15 out of 253, which is about 6%. All right, thank you for bearing with me with my technological troubles, and thank you for tuning in.